Good evening, students. So, in the last class on integration, we had of the properties or the special type formulas on integration. Okay, so we were discussing the 5 mark question on integration in the last class. So we will be continuing with some more special results. Okay, so in the last class we had completed two sets. The first set, okay, 1 upon integration of 1 upon x square plus a square dx. Okay, and then integration of 1 upon x square minus a square dx and integration of 1 upon a square minus x square dx. So this was the first set where x square and a square variable were not under square root sign. Okay, so that was the set 1. Okay, now in set 2 also we discussed the set 2 where all these terms were under the square root sign. Okay, so we discussed the integration of 1 upon root of a square minus x square dx, which is equal to sine inverse x by a plus c. Similarly, we discussed the integration of 1 upon root of x square plus a square dx. Okay, so which was equal to log of x plus root of x square plus a square plus c. Okay, and so on. So type 1 and type 2 derivations and some of the examples we had already covered based on that. Okay, so this question, 5 mark question, it will be occurring in the form of 3 plus 2 or 4 plus 1. Okay, so 3 marks will be for the derivation. Okay, so 3 marks will be for the derivation, and 2 mark will be for the example on that. Okay, will be awarded for the example on that. So most of the time this 5 mark question will be in the form of what 3 plus 2. Okay, 3 plus 2. So this 3 mark the special type formula or the property will be asked, and 2 mark example on that will be asked. Okay, students. So altogether till in the yesterday's class we discussed the 6 special types. Okay, 6 special types. In that 2 sets we discussed. Now similarly we will be discussing the third set. So see, I will be writing the sets here. See, type 1. Okay, type 1. So in type 1 we have integration of 1 upon x square plus a square. Okay, dx. Okay, next similarly next 1 upon uh, a square minus x square dx. Okay, and then 1 upon x square minus a square dx. Okay, so this is the type 1. Next in type 2 we discussed the same 3 we are discussing, but these we are considering under what square root sign. Okay, so there should be no confusion. So 1 upon root of x square plus a square. Similarly we have 1 upon root of x square minus a square dx, and then the last type is 1 upon root of what a square minus x square dx. Okay, so this is the type 2. Okay, so this type 1 and type 2, type 1 ಮತ್ತು type 2 ಏನದೆ ಡೈರೆಕ್ಟ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಬಹುದು. ಓಕೆ, ಟೈಪ್ 1 ಅಂಡ್ ಟೈಪ್ 2. ಓಕೆ, ಸೊ ಈಗ ಟೈಪ್ 3 ಡಿಸ್ಕಸ್ ಮಾಡ್ತೇವೆ ನಾವು ಇವತ್ತೆ. Okay, so we will be discussing the type 3 and examples on that. Okay, so in type 3, see the same type, but these are integration. So these all terms are present in the numerator. Okay, so it will be in the form of what x square plus a square dx. Okay, next integration of same x square minus a square dx, and then integration of root of a square minus x square and dx. Okay, so in the last class we have discussed type 1, we have discussed type 2. So today we will be discussing the proofs of this type 3. Two proofs I will be solving, and I will be solving the related examples. Okay, so for these two the proofs are similar. Okay, first two if you understand one, the second one you can do it very easily, and then the third type. Okay, so three are there. So out of these 1 and 3 I will be discussing. Okay, this is with the negative sign, so I will be discussing this. So this proof I will be, so I will be proving this, and also we will prove this. Okay, and then we will discuss one more example on this. So this part you can do it for homework. Okay, so if you do this 9 out of 9, any one will occur for 5 marks. Okay, it will occur for 5 marks. Mhm. So if you are, and today these three are very important. If you are perfect in applying these three, that is type 3, you can easily solve a question on application of integration. Okay, so this will make you ready for another 5 mark question on application of integration. Okay, so as per the new syllabus, okay, 7 marks are occurring from application of integration. Okay, so 7 marks are occurring there from the application of integration part. Mhm. As per the new syllabus. Okay, so there the question is been splitted. Okay, this question is been splitted. If you go through the blueprint there, okay, if you
Yeah,
go
na
through the
caption
blueprint, students, please mute yourself. Okay, keep your audio off. Okay, so you can hear me clearly. Don't disturb the class. Pay attention now. So type 1, type 2, and type 3 we have covered. And then see in the reduced syllabus this year, the blueprint, as per the blueprint, okay, as per the blueprint, application of integration is fetching you only 5 mark. Okay, so this 5 mark question can easily be attempted if you are perfect with the type 3 of the integration. Okay, this type 3 special types are there. So if you are perfect with 1, 2, and 3, you can also attempt the question on application of integration, because only one 5 mark question is occurring. So see, in the yesterday's class we have covered the 5 mark question on integration. Okay, that is the special types. So today another three properties if we cover, so this first full 5 mark question will be covered. Next we will try to cover this application of integration question, 5 mark. Okay, so in today's class, after finishing this, we will cover this, and then we will be going to the 6 mark question on integration, that is again based on properties, and that is again based on properties. Okay, and for 2 mark and 3 mark, I told you 2 mark 2 questions will occur, 3 mark 2 questions will occur here. Okay, in integration part. So for 2 mark and 3 mark, you need to prepare the substitution method. Okay, by parts and partial fractions. Okay, so if you are perfect with these, you can score around about say 5 marks. Okay, 5 plus 5 10, and 10 plus 6 it will be 16, 16 plus 4 20, and 26. So altogether 26 marks you can obtain here. Okay, 26 marks you can obtain from integration. Okay, from integration itself. Okay, and some more marks you can attempt in 1 mark section also. Okay, so see, altogether 25 marks. Here the this content is of 25 marks. So out of this 25 marks, okay, I'm helping you with these parts. Okay, this part I'm covering, 5 plus 5 plus 6. Okay, so 5 plus 5 plus 6, 16 marks out of 25 marks I am uh, covering here in the two sessions. So we will begin with the next part now. So we will begin with the proof of type 3. Okay, type 3. And for type 3, again we are making use of by parts. Okay, so I will discuss one simple example on by parts, and then I will continue with the type 3 of this. Okay, so this 3 mark question, or this may occur in 3 mark or it may occur in 2 marks, question on by parts. So this question will also get covered if you pay proper attention, and later try to solve some 4 to 5 example on by parts. Okay, so you can refer previous year's question papers and check out the examples on by parts and partial fraction. Most of the time a very easy example is occurring. Okay, so this 6 marks will get be ready. Okay, and minimum 5 marks. So altogether at least you can score 21 marks in integration. Okay, if you prepare these parts. Okay, so here you need to prepare the special types which we have which we are discussing. Here I will be discussing today's example, and because here if you have any doubt you can ask in the chat box. Okay, if there is any doubt or question based on the integration topic, you can ask. Then see, this 6 mark is occurring from properties. So this both I will be covering today. 5 plus 6. Okay, and the remaining part of this 5 mark question. So pay attention and try to understand, students. So when if you do this by parts partial fraction and these sections which we are discussing, easily you can score 20 marks at least out of 25 in integration. Okay, since the chapter is vast, covering each and every example and exercise is difficult. Okay, difficult ಆಗ್ತೈತಿ. ಅದರ ಸಲುವಾಗಿ ಏನ್ ಮಾಡ್ರಿ, ಇದ್ ಮೇನ್ ಪಾಯಿಂಟ್ಸ್ ಕವರ್ ಮಾಡ್ರಿ. ಮತ್ತೆ ಇದರ ಮೇಲೆ ಪ್ರೀವಿಯಸ್ ಇಯರ್ ಪೇಪರ್ಸ್ ನಲ್ಲೇ 3 to 4 year ಪೇಪರ್ಸ್ ನಲ್ಲಿ ಯಾವ್ಯಾವ ಕ್ವಶನ್ ಕಂಡು ಬರ್ತವೆ ಅದಕ್ಕೆ ಸಾಲ್ವ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ರಿ. ಸೊ ಮಿನಿಮಮ್ 20 marks at least you can score in integration. Okay, and this is helpful for engineering point of view. Okay, so differentiation and integration chapter are must. Okay, from integration point of view, mm, from engineering point of view. Okay, so prepare them properly. Okay. So we'll be focusing on this type 3. Pay attention. Yes. So we'll be discussing this. And already these all proofs have been occurred. Every year they ask for 5 marks. Okay. So you need to be ready with these proofs. Okay. So before discussing this question, we will discuss one simple question on biparts and how to make use of biparts. Okay. So if you know the usage of biparts, principle of biparts, then you can easily solve this example. Okay, so pay attention here. So here for using the biparts, okay, here it is the product of, okay, so we are taking the integration of what, product of two functions. Okay, first function, so u is the first, okay, and then v. Okay, so when two functions are involved, we are making use of biparts. Okay, we are making use of what, by parts. Okay, so u into v, so first function as it is integration of the second function dx minus integration of, okay, integration of the second function into d by dx of the first function into dx. Okay, so this is by parts. Try to pay attention here, and this is by parts rule. Okay, so see, pay attention here. So this is the rule: first function, second function. So this u is the first function, so you need to keep it as it is. You need to take the integration of v, and then see, we need to apply the integration twice. Okay, so see, in the bracket I have written integration of the second function and the derivative of the first function. See, here two steps are there. Okay, one is integration of the second function. Okay, integration of the second function and derivative of the first function. Okay, so both differentiation as well as what, integration. So this part is of differentiation and this part is of what, integration. And whatever the output you get, okay, so after solving this bracket, whatever the result you are getting, again you need to integrate it once again. Okay, you need to integrate it once again. Okay, so in some books directly they write double integration, but to make you understand the procedure, I have made use of this bracket, square bracket. So this square bracket, it indicates first you need to take the integration of the second function and then derivative of the first function, and whatever the result you are getting, you need to integrate it with respect to dx. Okay, so one simple example I will consider on this to make you understand by parts. So because if you know by parts, you can solve the property. Okay, or else it's difficult to understand. Okay, so say one simple example on by parts. Pay attention. So in by parts, okay, we will consider one simple example and apply the rule there. So integration of, okay, and again there is one more rule for John. Please off your, okay, video. Sharath.
Yeah.
So see, pay attention here. So again, so this is the property, and then we are making use of. So whenever we are considering this first function and second function, we are following a rule. Okay, that is order. So we are ordering the functions. Okay, by making use of this. Uh, okay, short form here. Okay, you need to remember this islet. Okay, it indicates, I indicates inverse trigonometric function. Okay, it indicates inverse trigonometric. L indicates logarithmic function. A indicates algebraic function. Then T indicates a trigonometric function, and E indicates exponential functions. Okay, so inverse trigonometric functions, all sine inverse, cos inverse, all the six inverse trigonometric functions. Then log x, log y. Okay, exponential functions. Okay, the algebraic functions, x raised to n, root x. Okay, such functions. Trigonometric functions, sin x, cos x. Exponential functions, a raised to x and e raised to x. Okay, so when this is the order we are following. Okay, so based on this order, we choose the first function and second function. Okay, so if in if in the example it is mixture of inverse trigonometric and logarithmic, so first you need to consider inverse trigonometric, and second you need to consider log function. Similarly, if it is mixture of algebraic function and exponential function, you need to give first preference for algebraic and then for exponential function. Okay, so this is the rule. Okay, so now making use of this rule, we will discuss a small example on this and then start with the properties and today's properties. Okay, so pay attention. We will discuss a simple example on this. Okay, so integration of, okay, integration of, we will discuss okay, integration of x square plus 1. Okay, x square plus 1 into log x. Okay, integration of x square plus 1 into what? Log x. Okay, so say according to the, okay, according to the by parts. Okay, according to the by parts, see, pay attention. Okay, according to the rule of by parts. Okay, so this will be the first function. Okay, the first function will be the exponential function, and the second function will be what? The algebraic function. Okay, our second function will be the algebraic function. So see, now pay attention how to apply the rule. So first function as it is, that is log x as it is. We need to integrate the second function, x square plus 1 dx minus integration of integration of see second function. Which is the second function here? Second function is x square plus 1 dx. Okay, into d by dx of the first function, that is log x. Okay, you can close the bracket into dx. Okay, so see, when we simplify it further, what do we get? See, so log x, you need to keep it as it is. Integration of x square plus 1 will be x cube upon 3 plus what? X minus. So first we are integrating the terms inside the bracket. So it will be x cube upon 3 plus x. Okay, into derivative of log x. Derivative of log x will be 1 by x into dx. Okay, so when we simplify it further, we get it in the form of, see, when we simplify it further, we get log x, x cube by 3 plus x. Okay, minus integration of, so I will multiply this x with these terms. So say x cube upon x, it will be x square. So it will be x square upon 3, and x will cancel. And it will be equal to what? 1 dx. Okay, 1 dx. So again, we need to integrate it further. So log x, keep it as it is. X cube by 3, x cube by 3 plus x as it is. Okay, minus. So see, now 1 by 3, I'll keep it as it is, and the integration of x square will be, see, integration of x square. So this 1 by 3, I'll keep it as it is. Okay, the integration of x square will be x cube upon 3, and then we have plus x plus c. So on further simplifying we get. So these are simple 2 mark questions. Okay, such type of questions will occur for 2 marks. Okay, so if integration of okay, if a little complicated question is occurring, then it will occur for 3 marks. But we are not discussing this much in detail. We are only discussing an example, so we can solve this property. So see, pay attention. This will be equal to 1 by 3. 1 by 3 into 3, it will be 1 by 9 x cube minus x plus c. Okay, so this will be the answer as per by parts. Okay, so here we have considered, just see the first function and the second function as per Eilert rule. Okay, so by making use of the same rule, now we will discuss the property. Hope the example is clear. If there is any doubt in any of the step, you can ask in the chat and put the question. So if you know this by parts rule, we can easily solve the property. If there is any doubt, you can put it in the chat box. Okay, no doubts. Okay, I see. While discussing, you can ask. Okay, so we will continue with the first property now. Okay, so say as per the first property, what we will be doing. Okay, so slowly first ಒಂದ್ಸಲ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊರಿ, ಆಮೇಲೆ ಮನೆಯಲ್ಲೇ ಮತ್ತೊಂದ್ಸಲ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ರಿ ಇದು ಕ್ವಶನ್ಗೆ. ಸೊ ಲಿಟಲ್ ಬಿಟ್ ಲೆಂದಿ, but it is easy. So say by parts. Okay, u into v dx, this rule we are using. So you can remember it. I'll write it on the top. U into v dx minus integration of v dx into du by what dx. Okay, so this is the rule we are using. So in the solution part, so we are considering the LHS. So see here the property is, we are throwing this integration of root of x square minus a square dx is equal to x upon 2 root of x square minus a square upon 2 log of x plus root of x square minus a square plus c. Okay, so see this we already know. Okay, this part of the formula we already know, because this is the formula for what integration of 1 upon root of x square minus a square. Okay, so in the yesterday's class we have discussed this property. Okay, so you need to see, very easy to remember also. X by 2 we need to take whatever the integral is given in the question, the same we need to write, and minus a square by 2 you need to write into integration of the property what we have used. Okay, so yeah, it's very easy to remember. So x by 2, the same integral root of x square minus a square by 2 log of what root of x square minus a square plus c. Okay, so see, pay attention here. We will discuss the proof for this. Okay. So first what we will do is we will consider this given LHS, okay, as I. Okay, I will consider it as I. So I is equal to root of x square minus a square dx. Okay, so now see here only one term is involved. Okay, only one term is involved. So another term I will consider it as 1. Okay, I will consider it as 1. So 1, see, it is a constant function. Okay, it is a constant function. 1 is a constant function. Okay, so what I will do is I'll consider this term. Okay, I'll consider uh, root of x square minus a square as the as the as the first function. I'll consider this as the first function, and this is easy to integrate. So I'll consider 1 as the second function. Okay, so see, pay attention. So by making use of by parts, see, I will be equal to now. Okay, by making use of by parts, I will be equal to pay attention. So I will be equal to, say, the first function as it is, that is root of what x square minus a square as it is, integration of 1 dx. Okay, I am applying by parts. So in place of v, you need to replace it by 1. So it will be 1 dx into d by dx of value of u is u x square minus what a square whole dx. Okay, so see, pay attention. So on simplifying this, we get, see, x square minus a square as it is. Integration of 1 is x. Okay, minus, see, integration of, again, integration of 1 is x into derivative of root of x square minus a square. So see, it is in the form of root f of x. So it will be equal to 1 upon 2 root x square minus a square into derivative of x square minus a square. It will be 2x dx. Okay, so see, here we can simplify some terms. 2 and 2 will cancel off. Okay, so this will be x into root of x square minus a square, minus, okay, minus, this will be x into x square. So x square upon root of what, x square minus a square and dx. Okay, so what we will do here is further, see, x into root of x square minus a square as it is. Okay, minus, okay, see this term, we are making an adjustment, we are adding a square and subtracting a square. So I'll write x square minus a square plus what, a square divided by root of x square minus a square and dx. Okay, so hope until here the proof is clear. Next step, again on further simplifying, see what do we get? I is equal to x into root of x square minus a square as it is, minus. See here, what we are doing is, see, x square minus a square, we are dividing the denominator. Okay, we are splitting the denominator. So see, it is in the form of, see, it is in the form of a upon root a, and we know the answer of a upon root a is root a. Okay, so x square minus a square upon x square minus root of x square minus a square, it will be equal to what, root of x square minus a square. So this will be equal to root of x square minus a square. And see, there is plus a square term. So this a square upon what, root of x square minus a square will be the second term. Okay, so see, when we split the denominator here, we get one part, we get it in the form of integration of root, I'm doing this directly, x square minus what, a square dx. Okay, minus, see, a square will remain as it is. See, this a square, this part, whatever this part is there with a square upon root. So this will be integration of 1 upon root x square minus a square and dx. Okay, next, see this whatever term we have obtained here. Okay, the second term is same as the given integral. See, I is equal to, see, whatever the first part in the first expression, whatever is there, the same term is obtained here. Okay, so this I can write it as I. Okay, I can replace it as I. So see, this I will be equal to x plus what, root of x square minus a square minus I. Okay, and minus a square. Okay, minus a square into root of x square minus a square. Okay, x square minus x square and dx. Okay, so since I plus I, it will be equal to 2i. 2i will be equal to x upon x square minus what, a square. Okay, minus a square into 1 upon root of what, x square minus a square and dx. Okay, so further what we can do. Okay, so see, the next step what we can do is, so we have almost completed it. See, this 2 I will be shifting it to the LHS, and we will be writing down the integral of 1 upon root of x square minus a square. Okay, so when we do this, the last step. Okay, so see, here I will do the last step. Last step I will do it on the top. When we simplify it further, say I will be equal to, I will be equal to, shift that 2 on the LHS, so it will be x upon 2 root of x square minus a square minus a square upon 2. So this 2 will get divided by, the 2 will divide the first term as well as second term. Okay, so here you will get by 2 for the first term, and again you will get by 2 for the second term. And then integration of root of x square minus a square is nothing but a log of, okay, log of mod of x plus root of what? X square minus what? A square plus c. Okay, so this is the required proof. Okay, so we require the integration of root of x square minus a square dx is equal to x upon 2. Okay, we have obtained x upon 2 root of what? X square minus a square minus a square upon 2 log of x plus root of x square minus a square plus c. Okay, so this is the required proof. Once again we will discuss the steps. So if the first derivation is clear, this proof is clear, the second one you can try it at home. Okay, and I will discuss the third one. So see, I is equal to root of x square minus a square, which is equal to, so we are considering, so by considering what we have considered the first function as second function. So I have considered the second function as 1 and the first function as what? X square minus a square. Okay, and we have applied the integration by parts. Okay, so see, first function as it is integration of the second function minus integration of the first function into a derivative of the second function. So here we have applied by parts. Okay, by parts rule use Devi. Okay, and then after that we have simplified it. Okay, integration of 1 will be x, integration of 1 will be x, derivative of root of f of x will be 1 upon 2 root f of x into d by dx of what? F of x. Okay, so x square minus a square, it will be 1 upon 2 root x square minus a square, and derivative of x square minus a square will be 2x. A square is constant, its derivative will be 0. Okay, so then we are multiplying x into x, it will be equal to x square. So to get the required term in the denominator, we are subtracting a square and adding a square, and then by making use of splitting of the denominator, we are getting two terms. Okay, the first term is x square minus a square upon root of x square minus a square, which is equal to what? Root of x square minus a square, and the second term will be a square upon root of x square minus a square. So the first term on simplification we are getting this, and the second term we are getting this. Okay, so in this trinomial expression you can see the second term is nothing but I, so we are replacing this with I plus I, it will be equal to 2i. First term as it is, third term also I am keeping it as it is. Next I am shifting I 2 to the LHS. So the first term will get divided by 2, the second term will also get divided by 2, and then finally we need to write the value for 1 upon root of x square minus a square, which is equal to log of x plus root of x square minus a square plus. Okay, so this is the required proof. Okay, next a very simple example will be asked on this. We will discuss one simple question based on this property. Okay, based on this property, and then discuss the proof for the next one. Okay, so pay attention. If any doubt is there in any of the step, you can write it in the chat box. I will explain it once again. So the properties are very important. One question is sure, but you need to practice it at least twice. ಎರಡು ಮೂರು ಸಲ ನೀವು practice ಮಾಡ್ರಿ. ಅವಾಗೆ clearly means confidently you can solve in the exam hall. Okay, so there will be no confusion. Okay, so pay attention. So this question has occurred in 2021 and not 21, 2019. Okay, in 2019 this question has occurred based on this property. Now we will discuss it. Okay, so the question will be for 4 plus 1. 4 plus 1. Okay, so see here the same based on this property the question has occurred. Okay, so the question over here is integration of, so say integration of root of 3 minus 2x minus x square dx. Okay, so this is a quadratic equation. First we need to convert it into a perfect square. Okay, into a perfect square plus some term. Okay, for this what we need to do is we need to see, first take out negative sign common. So see, in the rough work I will write it as x square plus 2x minus 3. Okay, so this will be the expression. So here you take the half coefficient of this, half coefficient of x. Okay, half coefficient of x, half coefficient of x is 2, so it will be equal to 1. Okay, so to simplify this, what we are doing is x square plus 2x, we are adding 1 and then 1 square and subtracting 1 square, minus 3. So when you simplify this, we get, see, x plus 1 whole square, this is x plus 1 whole square, and minus 1 square, minus 3, minus 1 square minus 3, it will be minus 4. Okay, so when you simplify this, we get 4 minus x plus 1 whole square, or this will be 2 square minus x plus 1 whole square. So this is just 10th standard part, and that is completing the square method you might have studied. So we have got it in the form of a 2 square minus x plus 1 whole square. So here we can express this given integral in the form of 2 square minus x plus 1 whole square and dx. Okay, so directly this you can do it in the rough work. Okay, and directly you can write 2 square minus x plus 1 whole square dx. Okay, 2 square minus x plus 1 whole square and dx. Okay, so this is of the type, sorry, see, this is of the type a square minus x square, a square minus x square dx. Okay, because constant is occurring first and then we have the variable, but here we have proved the property for what, x square minus a square. So I'll simplify this. See, pay attention, the formula for integration of a square minus x square dx, it is same. Okay, it will be equal to, see, the first term as it is x by 2 a square minus x square. Okay, plus a square upon 2, a square upon 2 sine inverse x by a plus c. So see, we will simplify this using this formula. So see, 2 square minus x plus 1 whole square, it will be equal to, in place of x we have x plus 1, so it will be x plus 1 upon 2 integration of a square minus x square. If you want, you can write this directly, 3 minus 2x minus x square. Okay, and then see, plus a square upon 2, a square, a value is 2, here a value is 2, so 2 square will be 4, 4 upon 2. Okay, 4 upon 2 sine inverse. Okay, in place of x we have x plus 1. Okay, and in place of a we have 2 plus c. Okay, so if you simplify, this will be the answer. Okay, so here this question has occurred, but it has occurred with respect to the next derivation what we are doing. Okay, so similar questions will be occurring. So most of the time such a quadratic equation will be occurring. Okay, so try to solve maximum quadratic equations, such kind of questions. Okay, so next we will discuss the proof of this property now. Integration of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse x by a plus c. Okay, so we will discuss the proof for this. Okay, so the 1 mark question will be of this type. So this I have discussed here. So such type. So prove that and also find the value of. Okay, so this derivation, if such type of type 3 are occurring, it will be 4 plus 1. So 4 marks will be for derivation, 1 mark will be for the example. Okay, so next this is the type 2. Okay, in the type 3, the second form, root of integration of x square plus a square dx is equal to x by 2 root of x square plus a square by 2 log of x plus root of x square plus a square plus c. So instead of minus sign here, plus sign is given. Only that is the difference. Okay, and the proof is exactly same. Again, you need to apply by parts and simplify. Okay, so this part you will do it for homework. Next, the third special type in this is root of what? Integration of root of a square minus x square dx is equal to 1 upon 2 x root of a square minus x square plus a square by 2 sine inverse x by a plus c. Okay, so the previous example which we discussed was on this formula. Okay, so we will discuss the derivation of this. Pay attention. Again, we are making use of the by parts. So along with me, try to solve on your own. If you get stuck in any of the step, you follow me here. Okay. So see u into v dv by dx. We know u into v dx minus integration of v dx into d by dx of what u, derivative of u whole dx. So same property we have to apply and simplify it. Okay, the same property we need to apply. Mhm. So see, pay attention, the last derivation in this part. So pay attention, the same step we need to apply. So consider the LHS. So the LHS is I is equal to integration of a square minus x square dx. Okay, a square minus x square dx. Again, we have to consider the first function 1 and 2. Okay, so this will be the first function and 1 will be the second function. Okay, so I will be equal to the first function as it is. So a square minus x square as it is integration of 1 dx minus integration of, see again we have v dx 1 dx into d by dx of root of a square minus x square dx. Okay, so we will simplify further. It will be a square minus x square, integration of 1 is x. Okay, minus integration of, again see in the bracket, first we will solve this integral. So 1 integration will be x into derivative of root of a square minus x square will be 1 upon 2 root a square minus x square into minus 2x. Okay, minus 2x, because a square derivative is 0, x square minus x square derivative will be minus 2x dx. Okay, so this 2 and 2 will cancel off. So on further simplifying, we get, see, I is equal to, we get it in the form of x as it is. Okay, a square minus x square. Okay, minus, okay, into
ಇದು
x
ಬರಲ್ವಲ್ಲೋ
again.
ಸಿಂಪಲ್ ಫೀಚರ್ ಬರಲ್ವಲ್ಲೋ
Just off the chat box. Off your audio, Rishi. If you have any doubt, you can ask. Hmm. Okay, so see, pay attention. So I will be equal to x into root of a square minus x square minus, okay, minus. So minus into minus it will be plus, and x into x it will be equal to x square upon root of, see, a square minus x square dx. Okay, a square minus x square dx. Okay, so here what we are doing is, 1 minute, pay attention. Don't simplify this, keep it as it is, so it will be easy for simplifying further. So minus sign you keep as it is, so there is a negative sign, and see here x into minus x, it will be minus x square. Okay, so there is another negative sign. Okay, so I will be equal to, see, I will be equal to x into root of a square minus x square. Okay, and then minus, see, I will be adding a square. Okay, and I will be subtracting a square. So add a square and then what? Subtract a square. Okay, and divided by, okay, divided by root of what we have, a square minus x square and dx. Okay, so again we have to apply the same step, that is split of the denominator. Okay, so see here we have a square minus x square minus a square upon what, root of a square minus x square. So first we need to group this part. Okay, and then we need to group this part. Okay, we need to group this part. Okay, so when we group this part, a square minus x square upon root of what, a square minus x square, In the previous derivation we discussed, it will be directly equal to minus root of a square minus x square dx. Okay, and then see minus into minus, it will be plus a square into 1 upon root of a square minus x square dx. Okay, so see this term is at least equal to I, so I will shift it here. So see 2I will be equal to 2 times I will be equal to x into root of a square minus x square. So say this second term is similar to I. So this I will substitute it as I and shift it to the LHS. So I plus I, it will be equal to 2I plus a square into integration of 1 upon root of a square minus x square dx. Okay. Now we want the value of I. So I will be shifting to the RHS. So it will be x upon 2 integration, okay, x a square minus x square plus a square upon 2 integration of 1 upon a square minus x square is log of, okay, it will be sorry, integration, yesterday we have discussed already, it is sine inverse what, sine inverse x by a. Okay, so on simplifying this we get, so the integration of 1 upon root of a square minus a square will be equal to sine inverse x upon a plus c. Okay, so this is the required result. So we had to prove root of a square minus x square dx is equal to x upon 2 root of a square minus x square plus a square upon 2 sine inverse x by a plus c. Okay, so this was the result we wanted to prove. Okay, so by integration of parts by parts, we can prove it very easily. Okay, so we have covered the type 1, type 2 and type 3. Okay, so in the last class we had covered type 1 and type 2. In today's class we have covered the type 3. Okay, so after solving, practicing the derivations, you try to practice at least two questions which have occurred in the previous year paper based on these special types. Okay, so this 5 mark question will be covered. Okay, next we will shift our focus on now application of integration. So based on this formula, okay, whatever the formula we have discussed now, integration of root of a square minus x square dx is equal to 1 upon 2 x into root of a square minus x square plus a square upon 2 sine inverse x by a plus c. Okay, so based on this formula we can easily attempt a question, 5 mark question on application of integration. So that we will be discussing now. Okay, so till here and this proof is clear. Okay, all have understood? Yes, students, are you getting it? You can reply in the chat box. Okay, okay, yes. So we will discuss few questions on now application of integration. Okay, so this was the 5 mark question on integration. Okay, every year the question is asked on the special properties plus one example based on this. Okay, and then directly we will, after covering application of integration, we will discuss the properties on definite integrals. Okay, so that is a 6 mark question, and there we will try to discuss some examples which are occurring on those properties. Okay, so pay attention now. So first we will cover application of integration part, and then we will discuss this definite integrals. Okay, so these properties we will discuss it. The proofs are very simple. We will discuss it later. Now, and examples on this. Now we will cover the questions on application of integration. Okay, so this is the first question. Now find the area of the ellipse x square by a square plus y square by b square is equal to 1 by the method of integration. So past 2 years, a very simple question is occurring because as per the reduced syllabus, area between the curves is cancelled. Okay, so since area between the curves is cancelled, the only question remains, okay, will be area of the simple curves. Okay, so simple curves are your ellipse, then circle and parabola. Okay, so only the questions will be asked on ellipse, area of the ellipse with x-axis, or area of the complete ellipse, then area of the circle, and then area of the parabola. So if these three types of questions you know, you can easily score 5 mark in this section. Okay, so here first we will discuss for ellipse, and then we will try to discuss a question on circle. Okay, so here we require the same concept or the same formula what we derived just now. Okay, so see, we have derived the formula on integration of a square minus what x square dx is equal to x upon 2 integration of a square minus x square, okay, minus a square upon 2, sorry, plus a square upon 2 sine inverse x by a plus c. Okay, so by making use of this formula, we can directly. Okay, so here they are asking us to solve it by using what, a method of integration. Okay, so for method of integration, first we need to draw the figure, and after drawing the figure, we can find out the required region or the required area. Okay, so in the solution, first we will consider the ellipse. Okay, equation of ellipse. Consider the ellipse x square by what, a square plus what, y square by b square is equal to 1. Students, those who are logged in now, just mute yourself. uh, Keep your audio off. Okay, so see, this is the equation we are considering this as equation 1, and then see, pay attention. So see, this is the ellipse in the standard form. Okay, so the figure, you need to draw the figure for this 5 mark question. So ellipse. Okay, so this will be the ellipse, origin, vertex A, and then what, vertex B. Okay, so see, we know the area of ellipse is equally distributed in all the 4 quadrants. Okay, so to solve this example, what we are doing is only we are calculating the area in the first quadrant. Okay, so area in the first quadrant. See the coordinates of this is on x-axis. Okay, so the coordinate of this will be a comma 0, and coordinate of this will be 0 comma b. Coordinate of the point a will be a comma 0, and coordinate of the point b will be 0 comma b, because of the length of the what, major axis. See, it is in standard form, the length of major axis will be 2a, but here we are taking the distance between what, origin and a, so this will be a comma 0. Similarly, this vertex will be a dash, and this will be b dash. Okay, so first what we need to do is, we need to write. Okay, we need to write the equation 1. So we need to simplify this equation 1 and convert it in terms of y. Okay, that is the first step, and then the figure. Okay, so see, first we will simplify this. Say y square upon b square will be equal to 1 minus x square upon what, it will be equal to a square, or y square upon b square will be equal to a square minus x square upon what, a square, or when we simplify it further, we get y square is equal to b square upon a square into a square minus x square. Okay, so I am shifting this b square to the numerator, and this denominator a square I am keeping it as it is. Or on further simplifying, we get y is equal to root of this. Okay, so root of b square upon a square will be b upon a. Okay, root of b square upon a square will be b upon a, and this term will remain under root. Okay, so it will be a square minus what, x square, and this will be our equation number 2. Okay, this will be our equation number 2. So whatever the equation is given, we are writing it in terms of what, y. This is the first step. So y is equal to b upon a root of what, a square minus x square. Okay, now using the figure, we need to describe the figure. So see, uh, okay, we need to describe the figure. So what we need to do here further is, we need to write the description, that is the area of what, ellipse is what, distributed equally, or it is symmetric. Okay, it is symmetric along what, both x and what, y-axis, and since it is symmetric about what both x and y-axis, we get the required area as. Okay, so here what we need to do is we need to write mm, area of ellipse is symmetric about both the axes, okay. So therefore a required area, so ra indicates required area, it will be equal to 4 times 4 into shaded area. Okay, so whatever area we have shaded in the figure, it will be 4 times of that. Okay, so required area will be equal to 4 times. So see, pay attention. See here, I am considering it, the area is bounded by x-axis. Okay, by x-axis, and see on x-axis the limit is changing from origin to the what point a. So here the integration will be from what 0 to a. Okay, because see the limit is x values are changing from what origin to point a. Okay, the curve is touching x-axis at point a, so we need to write integration from 0 to a. Okay, and y and dx. Okay, so on simplifying further, see 0 to a, we need to keep it as it is. What is the value of y? Value of y we have calculated here in equation 2. It is equal to b upon a, root of what, a square minus x square dx. Okay, so on simplifying, it will be 4b by a. Okay, integration of 0 to a, because b by a is constant, you can keep it outside. So it will be just integration of what, a square minus what, x square and dx. Okay, so this is third step. Okay, and then after this we need to simplify by making use of the formula. So you can see it is in the form of what, a square minus x square dx. Okay, so we have to make use of the same result what we have discussed in the previous. Okay, previous question we have discussed on this. So same formula we have to use and simplify. So we will discuss the simplification. Okay, so hope till here you have understood the example. Okay, so till here the example is clear. So first what we have done is we have converted the given equation in terms of y. Okay, here we are writing down the given equation in terms of y. This is the first step. Then we are drawing the figure, and after drawing the figure, we need to check the symmetry of this figure. So this area of ellipse is what, it is symmetric about what, both the axes. Since it is symmetric, whatever area is present in the first quadrant, the same area will be present in the second, third, and fourth quadrant. So for that reason, we are multiplying it by 4. Okay, so we are calculating it in one quadrant and we are multiplying it by 4. So this will be the second, third, and fourth part. Okay, so we are only calculating the area of the first part and then multiplying it by 4 to get the area in all the 4 quadrants. Okay, so up till equation 3 it is clear. The last step what we need to do is we need to simplify integration of what, root a square minus x square, and substitute the limits. Okay, so once we substitute the limits, we will get the required area. We will get the required area. Mhm. So see, the next step I will do it here. Okay, so figure is very important in this. Okay, once you, okay, curves are very important. Circle, parabola, and ellipse, hyperbola. So these all 4 figures you need to know, and also their standard forms. Okay, so further what we need to do, see now here. So the required area will be equal to, this will be equal to, see, 4 by b by a. I will keep it as it is. Okay, so I'll do write the integration directly. So we know the formula already. The formula is what, x by 2 root of a square minus x square plus what, a square by 2 sine inverse x by a. Okay, and it is under the limits what, 0 to a, so c won't occur. Okay, so see here on simplifying, 4b by a, pay attention. So first we are substituting the upper limit a. So when I substitute a, see here, if I substitute this term with a square minus a square, it will be equal to 0. Okay, so 0 into any term it will be equal to 0. Okay, and then see here in the second term we get a square upon 2 as it is, sine inverse, see a upon a. Okay, a upon a, it is nothing but it is equal to what? 1. Okay, because a divided by a, it will be equal to 1. Okay, then minus. Okay, so this is the first part. In the second part we need to substitute 0. So in place of x, replace it by 0. So 0 into any term will be 0. The first term will be 0, and then see in the second term we have 0. So it will be plus a square by 2, sine inverse of 0. Okay, so on simplifying further, what do we get? See, 4b by a as it is. Okay, so a square by 2 into, see, sine inverse 1 value is pi by 2. Okay, minus, see, a square by 2 as it is, and sine inverse 0, it is 0. So on simplifying it further, we get 4b by a into into a square pi upon what? A square pi upon 4. So 4 and 4 will cancel, 1 a square and a square will cancel. So the answer will be equal to pi ab. Okay, so pi ab is the area, required area of the ellipse. Okay, so pi ab square units, okay, will be the answer. Okay, so we have discussed one example. Okay, and such type of questions will be asked for 5 marks. Okay, so here a square and b square value was not given. Okay, in the next example what we are discussing, there a square and b square value is given. So just we will, I will be discussing a few steps, and rest of the part is same as this example. Okay, so this method is very important. First we need to write the equation in terms of y, and then we need to draw the figure, check the symmetry. Okay, and then simplify using the formula what? Integration of a square minus x square. Okay, so this formula is playing a very important role here. Okay, this formula. Okay, so you need to remember this formula. So next question we will discuss on application of integration. Yes. Okay, so this is the question number 2. Pay attention. So I'll be explaining you the figure, and I'll be discussing. So pay attention. As per the given question, see, again it is a ellipse only. It is given in standard form. So see, it is not given in standard form. We need to convert it in standard form. So 16y square is equal to what? 144. So consider this as equation 1. So first what we will do is we will divide it by the term in the RHS, that is 144. To convert it in standard form, always divide by the term which is present in the RHS. Okay, so this will be 9x square upon what? 144 plus 16y square upon what? 144 is equal to 144 upon 144. It will be equal to what? 1. So we need to divide by 144 on both the sides. Okay, this is the first step. So when we simplify, we get x square upon 9 upon 144. It will be equal to what? 16. 16 9s is 144, and 16 9s is what? 144. Okay, is equal to 1. Okay, so 9 16s are, and 16 9s are. So the equation will be of the type what? Okay, so this is the equation 2, and then we need to draw the figure. So first step we have done. Next, write the equation in terms of y. Now we know how to do it, so I am doing it directly. So this y square upon 9 will be equal to 16 minus x square upon what? 16, because we need to subtract it from 1, or y will be equal to, I'll do it directly, 16 upon 9 upon 16 into 16 upon minus x square. This is y square, or y will be equal to 3 by 4. 9 by 16 square root is what? 3 by 4. 4 square minus what? X square, root of this. Okay, so this will be our equation. This is equation 3. Now see in the figure, the figure is very simple. Again, it is in standard form. Okay, so the same figure we need to consider. Okay, now see same A vertex origin, B next B dash and A dash, y axis and x-axis. Okay, so see here origin. So see always 16, 16. Okay, so it is in the standard form. So when you compare it in with the standard form, x square plus what, y square by b square is equal to 1. See, in place of a square, what is there? 16 is there, and a value will be equal to what, 4. So this vertex will be 4 comma 0. Similarly, see, in place of b square it is 9, so this vertex will be what, 0 comma 3, and then again we need to shade it. Okay, so the required area will be again what, 4 times the shaded area, or the required area will be 4 times integral from say with 0 to what, it will be 4. So in the previous case, coordinates of a was a comma 0, but here coordinates of a are 4 comma 0. So integral from 0 to 4 y dx. Okay, so further the same steps you have to do. Equation 3 you will replace it in terms place of y, and then simplify. The answer for this will be the answer for this
Oh,
will be 12 pi. Okay, the answer will be 12 pi. You all solve it and try to get the answer. Okay, so the answer will be 12 by a square units. Okay. Similarly, I will try to discuss an example on circles now. Okay. So compared to ellipse, circle is very easy. Okay. But for 5 mark, the chances of ellipse are more. Okay. The chances of question on ellipse are more. Parabola and circle, the steps are very, means it's not that lengthy. Okay, but to sometimes if the examiner is little bit generous in setting the paper, okay, he will give circles for 5 marks. Okay, he will give the question on circles for my 5 marks. Okay, so we have discussed the question on ellipse. Now next we will be discussing the question on circle. Okay, so this is the question on circle. Find the area of circle x square plus y square is equal to 6 by method of what? Integration. Okay, by method of integration. Okay, so again the steps are same. First step is what, we need to write the given equation in terms of y. Then second equation we need to draw the figure and mark the shaded area. Okay. And then make use of the formula and simplify it. Okay. So it's involving 4 steps. The first step what we need to do, we need to identify whether it is a ellipse or whether it is a circle. So already in the question only they have given it is a circle. X square plus y square is equal to what, 6. So it is given in standard form. Okay, so the standard form of the circle is what, center is at origin. Okay, and its equation will be of the form what, x square plus y square is equal to a square. Okay, but here we can see in place of a square 6 is given. Okay, so see, pay attention. We will discuss this question. So Elaine, okay, again same. We need to consider the given equation x square plus y square is equal to what, 6, and then write the equation 1 in terms of y. So y square will be equal to 6 minus what, x square, or y will be equal to root of, I'll write it as 6 as root 6 square minus what, x square, and this is the equation number 2. So equation number 2 is, I've written y, the given equation 1 in terms of y, and y is equal to root of what, root 6 x square minus x square. Okay, so I have written root 6 x square to make use of the formula. Okay, so this is the equation 2. Next we need to draw the figure, circle. So for circle, okay, center at origin. Okay, draw a circle, y-axis, then again x-axis, origin. Okay, and I will shade the region in the first quadrant. Okay, so this I'll write it as a. Okay, the radius, yeah, this is in the standard form. So in place of a it is, say in place of a square it is 6. So a will be equal to what? Root 6. Okay, so the radius will be root 6. So this will be root 6 comma 0. Okay, the value will be root 6 comma 0. Okay, so again, see from the figure we can say the circle is what? Circle is what? Symmetric. Symmetric about both the axes. Yes, it is symmetric about both the axes. Okay, so required area will be equal to same. Okay, 4 times shaded area. See, we are only shading it in the first quadrant. Okay, so pay attention. The value will be equal to 4 into the shaded area can be calculated by what? See, 0 to root 6. The limits will be from 0 to root 6 y and dx. Okay, so here on simplifying further, see now a required area will be equal to 4 is constant, keep it as it is. Okay, so in place of y using the equation 2 we need to substitute the term. So 0 to root 6 I'll keep it as it is. Okay, and then integration of okay, integration of, see, as per the question it is root 6 whole square, root 6 whole square minus root 6 whole square minus what? X square and dx. Okay, so we need to simplify this. So 4 we will keep it as it is. So same formula we are using, root of a square minus x square dx. Okay, so using the formula we get it in the form of x by 2. Okay, integration of x by 2 integration of root 6 whole square minus what? X square dx. Okay, plus a square by 2. See, in place of a square we have root 6. So root 6 square upon 2 into sine inverse x by a. So it will be x upon what? Root 6. Okay, under the limits what it will be? 0 to root 6. Okay, so we will substitute the limits now. So once we need to substitute 0, next we need to substitute what? Root 6. Okay, so first we will try to substitute root 6. So when I substitute root 6 here, and this first term will become 0, and then root 6 upon root 6 it will be 1. So say it will be 3. I will do it directly because 6 upon 2 it will be 3. Sine inverse 1. Okay, so this will remain, and then minus. So when we substitute 0, this will be 0 into this term it will be 0, and sine inverse of 0 will be 0. The second term will be 0 only. Okay, so just sine inverse 1 if you substitute. So 4 into 3 it is equal to 12 into what? Pi by 2. So when we simplify, it will be equal to what? 6 pi. Okay, the answer will be equal to 6 pi square units. Okay, will be the area of the circle. Okay, so such type of questions are been asked for 5 marks. Okay, so this is the another question on 5 marks. So for homework you can practice 1 or 2 questions on parabola. Okay, on parabola, but maximum of the time past 2 years the question on ellipse has been asked in the model papers and the previous year paper. So try to solve 2 or 3 questions on ellipse again. Okay, so this completes your application of integration. So next again we will be shifting our focus on the 6 mark questions now. Okay, 6 mark question on integration. Okay, so if you want you can get ready with this 6 mark question, or already we have discussed LPP. Okay, we have discussed LPP. So if you are perfect with LPP, need not worry about this question. Okay, need not pay much attention on this question. Okay, or if you are not perfect with LPP, you want, or if you want to attempt one extra question in part E, that is 6 mark question, then you need to prepare the question on properties on definite integrals. Okay, so this is the last section we are discussing. So just we will discuss the properties, the proofs we will discuss it tomorrow, and then solve a model paper on this. Okay, so we will solve a model papers or a previous year paper tomorrow. See, pay attention here. So we will discuss the properties. Okay, so properties and examples. Okay, so this is the last part. Okay, so altogether seven properties are there. Okay, so you we need to know these seven properties. Okay, so see the first property is from integration of f of x, integration from a to b, f of x dx is equal to what? Integration a to b f of t dt. Okay, so this is change of variable property. So x we can change it to t. Okay, without changing the limiting values. See a and b, whatever the upper limit and lower limit is there, without changing that, we can change the variable. Next, a second property, a to b f of x dx is equal to minus b to a, integral from b to a f of x dx. Okay, so when we interchange the limits, the value of the integral will change its sign. Okay, this is the second. Next, third one, say 0 to a f of x dx is equal to what? 0 to a f of a minus x dx. Okay, so this is the third property. Similarly, a to b f of x dx is equal to a to b f of a plus b minus x what dx. Next, we have a to c f of x dx, where c b is lying between a and b, and then we can split this a to c as a to b and b to c. Okay, so f of x dx plus f of x dx. Okay, so here this we are splitting it. First we are splitting it to a to b. We are splitting the limits from what? See, first we are writing the integral for only and applying the limits from a to b, and then we are applying it from what? A to c. Okay, but in the question it's given from what? A to c. So instead of going directly from a to c, we are splitting it as a to b and b to c. This is the property number 5. Okay, and then we have property number 6. Okay, property number 6. So maximum time the question on 5, 6 and 7 is asked. Okay, 6 mark question is asked on 5, 7 and 6. Okay, so say property number 5. Okay, property number 6, minus a to a f of x dx is equal to 2 times 0 to a f of x dx if f of x is given, or it will be equal to 0 if f of x is odd. Okay, so say minus a to a, limits are from what? Minus a, so upper limit is there and negative limit is there, and then say this f of x, the integral of this will be equal to 2 times 0 to a f of x dx if the given function is a even function. Okay, so you need to know what is even function and what is odd function here. Okay, and hope you know also, just I will discuss it in short. So see, if f of x for a given function, see for a given function, for a given function f of c minus x, if it is equal to f of x. Okay, and f of minus x if it is equal to minus f of x. So see, the first is the example for what? Even function. So definition of even function is, even if you replace the function with negative variable, you will get the value as it is. Okay, and when you replace for odd function, if you replace x with negative variable, we get it as minus f of x. Okay, see, simple example I am taking, x square and what? X cube. So if f of x is equal to what? X square. So even if you replace x with minus x, the square of what? Negative term will be what? Again x square only. Similarly, if f of x cube I take, so if I take minus x, so it will be equal to what? Minus x cube. Okay, or mhm. There are so many examples on this. Okay, so we will discuss it. Okay, we will discuss this while discussing an example. Then we have seventh property, 0 to 2a. So this 0 to 2a, again it is equal to 2 times 0 to a f of x dx. Okay, same like this. See, same property, it is 2 times 0 to a f of x dx. Here also it is 0 to a f of x dx if the condition is changed here. F of 2a minus x must be equal to plus f of x, and it will be equal to 0 if f of 2a minus x is equal to minus f of x. Okay, so it is same like even and odd function, but see the limits are changed. In case of even and odd function, we are using the limits minus a to a, and here we are using the limits as 0 to what? 2a. Okay, so the proofs of all these we will discuss tomorrow. and within half an hour we can wind up this. So the proofs from 4 to 7 are important. So 4, 5, 6, 7, all these proofs we will be discussing. And the remaining properties are important, but proofs are not that lengthy. So for that reason they don't ask in the exam. So maximum they ask 4, 5, 6, and 7. Okay, so we will prove them and discuss the previous year questions on this. Okay, so today we will stop here. Remaining we will continue it in the next class. Okay, so remaining part we will continue into the next class. Okay, till then take care. Bye students, and prepare properly for the exam. Almost we have covered 70 85 marks, okay, in these 2 months, 2.5 months. Okay, so revise them properly. You can go through the videos, the questions what we have discussed, practice them once again. Okay, and get ready. So from next week you have your exams. Okay, so get ready. All the best. So we will meet tomorrow. We will discuss a model paper and then wind up these sessions. Okay.